what I'm going to do is take care of, think of it like an order of operations. I'm going to take care of the parentheses stuff first, and you'll notice you're going to get 2, and then you'll have log base 6 of 15 over 5, which is what? 3. Okay. So you get 2 log base 6 of 3, which is 2 log base 6 of 3 squared, which is log base 6 of 9. You okay with that? I took care of all that side first. And then the next part was plus, well, 1/2 log base 6 of a 25th means that it's going to be log base 6 of 1/25th to the half. And what did the half power mean again? Square root. So what's the square root of 1/25th? And then when you're adding logs together, what are you doing to the values after the logs? Multiplying, so what's 9 times 1/5? 9/5, and you get that for your answer. Go piece by piece, and it's quick. Okay. I know that that's come up numerous times throughout, not just today or yesterday, over the course of the years. It's one of the problems people go through. Speaking of it, what's 9 times 1/5? Good conversation. Any others? We okay? Make sure your name's trying to set it up. Let's talk about equations. Why do you complain? What does it mean? No. We're solving trig equations in trig equations. Sorry, long time to talk about trig equations. We're not there yet. We'll get there. When we're solving and working with exponential and logarithmic equations, it is again the same idea of working backwards through properties. So one of the properties that you're going to see that shows up over and over again is the idea of the log base b of x is equal to x, and b to the log base b of x is also x. These two properties here are the ones that we're going to use to our advantage to help undo logging, to help undo natural logs, to help undo really any base, so that way we can get x by itself. Remember, whatever you do to one side of an equation, you have to do to the other, because numbers are always inherent. Numbers are inherently jealous. They're like siblings. I know, my brother got G.I. Joe. I didn't get G.I. Joe. Sure. The joke. Sarcasm. I was just. Anyway, so here's what happens. You're going to get stuff that looks like this, and you may or may not have noticed that I left a note here that says, we might be able to solve this by getting a common base. So we have 4 to the 3x, and we're going to say that equals 8 to the 1 to the x plus 1. And in order for us to be able to get those exponents out of the exponent land, what we have to do is we have to get them to fall. In order to get an exponent to drop, you have to do a log base the same thing to both sides of an equation. So in order to do that, what base can I rewrite 4 and 8 into? 2. 4 written as base 2 would be 2 squared. So this is 2 squared, and then b times 3x. This is 2 cubed x plus 1. You okay with that? Now, here's a shortcut. Are those the same bases? Okay. that means they just fall. The reason why you can do that is because if I take the log base 2 to this side, I'd have to take the log base 2 of this side. What's the log base 2 that has junk above it? It's just the junk above it. So they undo each other. They undo each other. I kept it consistent to both sides of the equation just by log basing both sides. So now I get 6x equals 3x plus 3. And I'm pretty sure we could probably solve that equation. Okay, I'm pretty sure some of you could solve that equation. Okay. Subtract 3x. Yeah, we're using those rules to get it to drop out. Yes, ma'am. I do. It's just my habit. That way I don't accidentally forget that it's up as an exponent as opposed to an exponent. Guys. And that's about all you have to do. Yeah. But remember, that was example number. Okay. That hasn't shown us this. It didn't look as nice. Can I rewrite 7 as a base 2? I could, but I don't know how. So I need to figure out a way again to get the exponent to drop. So what do I do to 2 to the x undo the exponent? I log base 2 of it. So if I take the log base 2 of both sides, what do I get on the left-hand side? X. And now I just get some crummy number. That's the log base 2 of 7. Do we know how to press the buttons on the calculator to do that? Yes. Yes, sir. It's because when you have it set up that way, because exponent and log form are inverses of one another, we're using inverse operations. That's in your right, Colby. That's exactly what we're doing. For this style problem, for this one, that's exactly what you're doing. Okay. Remember, to get to your log stuff, you have the alpha window 5s. Like I said earlier, I think the alpha window 5s and the mighty asymptotes will be my new band name. Or alpha window 5. Alpha window 5 and the mighty asymptotes sound like a cool band name. Okay. Yes, sir. There's other log buttons. If you look at the regular log button, that's what log base is at. 10. Alpha window 5 gives you your change of base. Okay. Now, you're right, there's another way of going about getting there. You can go into math, alpha math, or whatever it is. There's all these different ways of getting, that's just A. Oh, yeah. Oh, I see what you're saying, yeah. There's a couple of ways of going of getting there. The shortcut key is just, I'm used to seeing, alpha window 5, and it gives you my quick keys. Okay. And you just type in a calculator. Always round it 2 decimal places and go from there. Okay. Oh, whatever the answer was. Okay. Add more steps to it. As we add more steps to things, you still are going to use your order of operations in reverse. We're still going to SAD map it. We're still going to SAD map all this. So, what do you do first? Subtract 4. do I get that 2x minus 3 to drop from the log base, from the base 10? And log it. What's my base? 10. So do I have to use alpha window 5 for this one, or can I use just the log button? Would I be wrong going either way? No. Now, watch what happens here. You take the log here, you take the log here, and you get 2x minus 3 is the log of 17. When you type in your calculator log 17, it's just some crummy decimal, isn't it? Okay? You get some crummy decimal. So you have log 17, hit enter. And I'm guessing from here, you could probably know how to get x by itself just by pressing buttons. What would you do? Add 3, so you hit plus 3. Hit, oops. Number 3. And then what? So in order to solve some of these types of equations, what do you have to have with you? Calculator. Okay. Correct. What's that? 2. Always go 2 decimals, please. So this one would be 216. Okay, let's go 216. I'm sorry, I was looking at. Sorry. I glanced over and I thought it was size 6. Sorry. My bad. Same idea. Sometimes you'll have log equal log. Exactly. And what happens here, if these logs happen to have the same base, they just cancel each other out. The reason why they cancel each other out is because how do you undo a log? You would with reverse integration. Thanks, Alex Trebek. Pete spoke to him. You exponentiate it. Remember that word I talked about yesterday? I exponentiate it. When you exponentiate something, you're actually doing this. B, the log base B of x is x. You're undoing the log base B. And in order to undo the log base B here, you would exponentiate it to the same base. So you make 3 the base of the log of an exponent of the base of 3. It's a long-winded thing of saying, if the logs bases are the same on both sides, they both drop out, and you're left with 5x minus 1 equals x plus 7. So you get 5x minus 1 is x plus 7. X equals 2. It is a very weird way of writing 2. I'm getting there, yeah. What'll happen here is, remember, you can't take logs of negatives. Bless you. You can't take logs of negatives. So you'll have to go back and just double check your values of x. Just in case you do substitute in and get a negative value, make sure it doesn't work. Or make sure you don't get a negative. Excuse me, rephrase that incorrectly. Okay? Okay? So I have log base 2 of the quantity x plus 2 equals log base 2 of x squared. So the log base 2's cancel each other out, so I'm technically exponentiating both sides with the 2. And I get x plus 2 is x squared. Which means you have to do what? Factor. 0 is x squared minus x minus 2. What times what is negative 2? Yeah, together again, negative 1. Negative 2 and 1, very good. Gives you zeros at 2, negative 1. So You double check then. Will the negatives work?
Yeah.
They both work. No, I said they both work. They both work. So, like Colby brought up a second ago, do we have to check for extraneous solutions? Yeah. You always want to double check. Okay. Especially when you see those negatives. So you've got negative 1 plus 2 is 1, negative 1 squared is 1, and you know it's going to work. Okay. Chippy, I know you see you got to fail. That's cool. Don't worry about it. You'll be, I'm pretty sure you'll be okay. Maybe. What? Yeah, sweetheart. I shouldn't be. Quick, hide his stuff. So if I have log base 5 of the quantity 3x minus or 3x plus 1 equals 2, I need to get the, as I go through this, how do I get rid of the log base 5? I exponentiate it with a 5 on one side, which means what I do over here. So I get 5 to the log base 5 of 3x plus 1. These two undo each other, so I get 3x plus 1 is how much? Pretty quick, isn't it? A lot of times what people do with that 5 to the 5 squared part, they'll just write underneath there and they'll think you're multiplying the right 10. Don't do that. You're making that 5 a base with that numerical value of exponent. Okay. So what times 3 plus 1 is 25? 8. Yes, ma'am. Can't do it. Nope. Yep. The book doesn't even give you anything like that. Don't even worry about it. Okay. Maybe. Well, what's your answer? No solution. So why would I waste my time? You have to have, in order for any of this stuff to work, you have to have common bases. So if you have one log base 5 here and this is a log base 2, this won't, none of this works. Okay? Okay? Sometimes you get into this, there's multiple ways to solve. Okay? I'm going to show you 2 different ways to solve this. You have 15 plus 2 times log base 2 of x equals 31. There's another way that you could write this. The other way that I could write this, because remember how we did all the condensing and expanding yesterday? The other way that I could write this is I can take this and write it as 15 plus 2, plus log base 2 of x squared. Because that means the same thing, isn't it? Okay. Means the same thing, but you're right, Bradley. Is it? So working via order of operations, what are you going to move? I'm going to do the one on the left first. What are you going to move first? 15. All right. 31 minus 15 is how much? All right. So you have 2 log base 2 of x equals 16. Now, if you're in your mind, you're thinking it's 2 times the log base 2. How do you want to do that? Divide by 2. Okay. So if I divide by 2, I get log base 2 of x equals 8. Which means what do? I exponentiate it with a 2. 2 to the log base 2 of x is just x. 2 to the 8th, I think, is 256, if I'm not mistaken. Reason I remember that, because it just last hour we did 2 to the 7th, and I remember it being 128, as opposed to 220. Come on, I set you up finally. You're like, eh. I am too. Go to the other side. What am I going to do first? Subtract. So I still have log base 2 of x squared, 16. To it. Now, see, we're one of two things. You can type in 2 to the 16th and get some really god-awful large number. Or, how do you undo squaring? You square root it. What's the square root as an exponent again? What is square root as an exponent? Square root, thank you. You know, it's a giraffe. I don't know, it's this animal. It's like, it looks like this. It's, there was this tiger that was running around. And it came up and it took a bite. Oh, it brought his teeth. And you're like, I'm gonna eat you, and it ate it, and that's why the giraffe is missing a part of its butt. There are some moments that I really don't know what's going on in my mind, so I apologize. Anyway, so when I take the square root? Square root is what as an exponent? You're right, it's giraffe. So it's the same thing as doing a half power. And half power, what do you do? When you have power to power, what do you do? What's half of 16? You get the same answer. The reason, sometimes people see it because they think, oh, I've got a number out in front, I can rewrite it as. You have to, I'm sorry. Sue me. What I'm getting at here, guys, is sometimes if you condense things, because if that's the way you see it, you're still going to get the right answer. It might take a step 2 more or whatever, but it still works. But sometimes you might actually have to condense something to be able to solve it. Really. For example. You like that? I like, it's this whole idea of scaffolding. You notice how I start with the easy and it gets a little bit more and more complicated as the day goes on? You guys, one of these days I'm just going to start with the worst stuff and just kind of work backwards. You'll be like, man, this stuff's easy. So in this case here, I can't tend them because of the addition between. What I mean by tend them is I can't exponentiate it with a 10 base going all the way across. I can't do that over addition. Okay. So we have to condense first. Well, I can't subtract. When I have addition between two logs, what am I doing? Thank you. You're multiplying. So you get log of 5x times x minus 1 equals 2. Now how do I get rid of the log? Exponentiate it with the base of 10. So I get 5x squared minus 5x equals 100. Very good. What? Thank you. So now I'm just getting rid of my GCF, and I get x squared minus x minus 20. What times what's negative 20? You add together to get negative 1. Correct. Which now gives me my zeros of 5 and negative 4. Okay. And then I go back and see if it works. So when I go back and look at that, if I substitute in negative 4, I get log of negative 20. Correctamundo. Uh-oh, SpaghettiOs. Sayonara, sucker. Can't take the log of a negative. Logs are, you always take the log values and constant value. What's up, man? Door's open. I actually left it unlocked for a change. Do you have gifts? Can we shake them and throw them at people? Corey! No, that's me. I'm gonna start shaking these because it'll be fun. Thank you, sir. I am going to shake them. Whoa. I may or may not show a lot. Do not make a spill or a mess or. So I need to show you the scary problem. Every other thing I showed you that you can have natural logs of this.
No.
I did.
No, you didn't.
I did.
No.
Yep.
Teach me again.
Remember yesterday I showed you guys that you're gonna have natural logs of this stuff?
I don't even have this teacher. I do not have like you have the same like the second year.
If I'm not mistaken, guys, yesterday I believe I gave you this problem. I think we talked about this type of a problem yesterday when we were looking at how to solve for x. And we talked about why we needed to, we talked about why in fact we needed to know how to condense stuff. Basically a dead giveaway of why you have to condense things in equations. If you see more than one log or more than one natural log, you have to condense it to one of them to be able, more than one of them on one side. All right, then you have to condense them to make it work. So if I have natural log of x plus natural log of x plus 3, what does that actually mean? Multiplication, okay? So that means I have natural log of x squared plus 3x. I'm just putting it together right now. I think you said, what was natural log? I think you were saying it just a second ago. What's natural log as log base? E. So natural log, remember, I thought you said it, I'm sorry. Natural log is the exact same thing as saying log base E of all this stuff here. No, it's just an E. All right. Which means, what do I have to do to both sides? So we have to E it. Just eat it. So, on the left-hand side, you get x squared plus 3x equals E. Now, if you look at your calculator, you have two separate button functions for E. One of them says e to the x, the other one just says E. I believe the E button is by division, and the e to the x is by natural log. If you press the one that says e to the x, it automatically thinks that it needs a cursor, it needs a value for what exponent. If you hit the button by the division symbol, it just gives you e, and it just means it's e to the first power. All right. Again, we have to set aside equal to 0 in order to solve this. So we have x squared plus 3x minus e is 0. So what times what is negative e that adds together to get 3? But I bet you remember this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So yes, quadratic formula still comes into play with exponential and logarithmic quadratic equations because it's still the same format. Okay? So you start filling it in. If, believe it or not, it works rather quickly. You get negative 3 plus or minus the square root. We get 3 squared, which is 9, minus 4 times 1 times negative e. Because of the coefficient's negative 1, all over 2. So what I want to do first is I want to figure out what my discriminant is. What is the discriminant again? Under the square root. What's the square root's power as an exponent? So I type in my calculator. Let me move this out so I can see it. 9 minus 4 times 1 times negative e. I get some crummy decimal. I need to take the square root of said crummy decimal. Second square root of my answer, I get 4. 4.46. You okay with that? What's wrong, better? Times negative e. Answer is second in the negative symbol. Okay. Now, in this case here, what I want you to think about is we're using quadratic formula, and we're getting the stuff underneath the radical is equal. So right now we have negative 3 plus or minus 4.46-ish over 2. Can I take the log of anything that's negative? Can I take the natural log of anything that's negative? So which one don't I have to worry about? The minus. In this case, I won't have to worry about the minus. I don't have to put it together. So all I have to do with this values in my calculator right now, I have that 4.45, as you just said, subtract 3, hit enter, and divide it by 2. And there's your answer, 0.73. Yeah, because it was negative 3 plus or minus the square root, so I did the root first, the negative 3 was out in front. So it looked like it was awful, but it really wasn't that. It happens.
It shouldn't. Math shouldn't happen. It should have math. Don't question how this works.
That's about as bad as this gets, where you'll have to use a quadratic formula. Okay. Don't freak when you see the problem set. I know it looks really, really weird, but I have you skipping a lot of negative, weird setup values. And it was easier just to write it. I've seen people that started on this and they got over halfway done in like 15 minutes. I'm sorry, it probably took them 15 minutes to do all of it. This is really, really, really fast. Tomorrow what we'll do, we'll go through some of these. I made a quick little review thing that will remind ourselves of some formulas, how things are quick set up, expanding, condensing. We'll try to knock all that out real quick. This should be a really, 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 really easy test stuff for us. I'm not lying. What's that? Yeah. Friday. Exponentials, and to be honest with you guys, you do basically the exact same work next year in pre-calc, no matter what level, whether it's regular or honors. And it's one of those that most students just ace. Okay? Which is good. Sets you up with good grades. Okie dokie.
What's that?